Okay, so let's go to the second example. Now in this one we need to find the surface area of the portion of the paraboloid, say equals to x squared plus y squared, that lies inside the cylinder x squared plus y squared equals 1. Okay. Now let's draw the figure. So here we have the x, y and z axis. Now let's draw the paraboloid. It should be, let me draw it again. It is a paraboloid like this. This is the paraboloid c equals to x squared plus y squared, and then we have a cylinder with radius 1. We have a cylinder with radius 1. It's a cylinder, and the equation of this cylinder is x squared plus y squared equals to 1. Okay, now in this example what we do is we are going to calculate the surface area of this portion. Okay, now we know that surface area equals to double integral of square root of 1 plus f sub x squared plus f sub y squared dA over a domain D. Now in this one our f is this x squared plus y squared, okay, because that's the surface. So f sub x, which is partial f over partial x, equals to 2x f sub y equals to 2y. Okay, now we can update our formula. We have double integral over a domain D of square root of 1 plus 2x squared plus 2y squared dA. F sub x is 2x, f sub y is 2y. Okay, now what is D? Well, if we look from the top, then you will see this circle, this circular disc. And if you project this circular disc onto the xy plane, you will see a circle with radius 1. So now your domain D is this. X squared plus y squared equals to 1, circle with radius 1. Because if we consider the intersection of the cylinder and the paraboloid, you will see this circle and its radius is 1. Okay, now so this is your domain D, this part is your domain D. Okay, let's simplify the integrand. If you do that, you will get 1 plus square root of 1 plus 4x squared plus 4y squared dA. Okay, now of course we could solve this integral using Cartesian coordinate system, but at this point we learned about the polar coordinates. Your domain is a circle, and here you have 4x squared plus 4y squared. So this is a hint. These two are hints to use the polar coordinates. Okay, so let's use polar coordinates. Let's use polar coordinates to solve the integral. Okay, in polar coordinates, x squared plus y squared equals to r squared, and dA, which is area element, dA equals to r dr d theta. R dr d theta. Okay, now let's update our surface area formula. You will get 1 plus. If you factor out 4 from these two terms, you will get 4 times x squared plus y squared dA but x squared plus y squared equals to r squared, so you have 4r squared. dA is r dr d theta. Okay, now let's figure out the limits. Okay. R is the radial distance from the origin. Okay. Therefore the lower limit of r should be 0, and the upper limit of r is given by this circle, and this distance is r equals to 1, and theta is the angle goes from 0 to 2 pi. Okay, now at this point, to evaluate this integral we need to use substitution. Let's take u equals to 1 plus 4r squared, so that's a complex part, 1 plus 4r squared. Okay, so what is du? Du should be derivative of this part, which is 8r dr. Okay, 8r dr. Now our integral becomes 0 to 2 pi. Then we have the inner integral. Now instead of 1 plus 4r squared, I can write u. So basically we have square root of u. Now what is r dr? What is this r dr? Now r dr should be from this du over 8 equals to r dr. Okay, so now we have du over 8. Okay, at this point we need to figure out the new limits for this inner integral, because we change our variable. Initially we had the variable r, but now we have the variable u. Okay, so usually what I do is I make a small table like this. we know that r goes from 0 to 1, and this is the way we connect u and r. Okay, if r equals 0, then u should be, if r equals 0, u should be 1. If r equals 1, u should be 5. Okay, so then this inner limit should be 1. The lower limit of the inner integral should be 1, and the upper limit of the inner integral should be 5. Okay, so let's solve this integral. We have integral from 0 to 2 pi. If you want, you can factor out, or you can pull out this 1 over 8 term. Okay, let's do that. You have 1 over 8. It's a constant. So now you have inner integral that goes from 1 to 5 of root u du d theta. Okay, integral of square root u should be u to the power 3/2 over 3/2, because this is u to the power 1/2. If we integrate u to the power 1/2 with respect to the u variable, you should get u to the power 1/2 plus 1 over 1/2 plus 1. Okay. After that, we need to apply the limits. So this is the value of the inner integral. Okay. If we apply the inner integral, you will get 5 to the power 3/2 minus 1 to the power 3/2 all over 3/2 d theta. Okay, now this entire quantity is a constant, and we can pull out a constant from the integral sign. Then you will get 1 over 8 times 5 to the power 3/2 minus 1 over 3/2 times the integral from 0 to 2 pi of 1 d theta. If you integrate 1 with respect to the theta variable, you will get theta. Lower limit is 0, upper limit is 2 pi. Now if you apply this limit, you should get 1 over 8 times 5 to the power 3/2 minus 1 over 3 over 2 times 2 pi. Okay. Now if you want, you can simplify this final answer. In that case, you should get 1 over 8 times 2 over 3 times 5 to the power 3/2 minus 1 times 2 pi. Okay, so it should be 2. The answer should be 5 to the power 3/2 minus 1 times pi over 2 times 3 is 6. Okay, so this is